chance, don't get too frustrated with it, and if I need to repeat myself, let me know, okay? Alright, so, trigonometry is a Greek word, okay? It's for the measurement of triangles, alright? Which we've already seen a lot of what we call right triangle trigonometry. All of it can go back to the right triangles. You can always default to that. There's other parts of it, okay? And yesterday we had all these words. These should be things that you are familiar with, okay? And as we're going through this, it's not bad to annotate your notes on the side. Okay? There's going to be a couple places where I'm going to say, hey, you should write this down, okay? And you'll get your little comments in the list of 1 or 2 comments in the left-hand column, right? So, an angle is determined by rotating a ray or a half line about its endpoint. So this is an angle, this is another angle, right? An initial side is the starting position of the rotated ray. So we have a side that we start with and a side that we start with, okay? The terminal side is the position after the rotation. So basically they're saying you take this initial side, you write it, or you draw it, and then you take it and you rotate it, and that's what we call the terminal side or the end side. The vertex is that point where the 2 rays come together. The vertex we've learned in elementary school somewhere. Okay? An angle in standard position when the angle's vertex is at the origin of a coordinate system and its initial side coincides with the positive x-axis. So we are going to probably put all of our angles on the coordinate plane. Okay, that's the transition of taking it from right triangle trigonometry to still based on triangles, but trigonometry. Okay, we see it in the rest of the world. Okay. You might want to write down and make a note that the initial side is always, or highlight this, always on the positive x-axis. Initial side is always on that positive x-axis. Okay. It's important to know. Everything else is terminal from there. Okay, then we are going to talk about positive and negative. So last year in geometry, you didn't have any negatives hardly at all, right? Because you can't talk about negative sides of an object. You can't talk about negative angles. But negative angles do exist when we put them on the coordinate plane. A negative tells us, and positive tells us which direction we are going. So a positive angle is generated by going clockwise. I'll show you where to remember that in a minute. So go clockwise. A negative, sorry, I think I said that wrong. I pointed the right direction. We go counterclockwise for a positive. To do negative, we go clockwise. So for a positive, you go up first. It's like we think positive is up, right? Negative, you go down first. Okay? Alright. Angles are coterminal. So basically that means they have the same initial side and the same terminal side. That kind of seems weird to us because we have not seen angles, we've seen congruent angles, but they were separated from each other, right? But they have the same angle measure. So what they're talking about here is that if I have an angle that maybe lands in the 3rd quadrant, last year your angles only just stopped at 180 degrees, right? When we put it on this coordinate plane, we can now go bigger than 180 degrees. Okay? So if we know if my angle lands here in the 3rd quadrant and I want to do the negative angle, so they have the same ending place. So we would say those 2 angles are coterminal. This is just so you know an alpha, another alpha, and this one here is the letter beta. Okay. Instead, because it gets boring to just use theta all the time, right? Theta is what we typically use for an angle. They will switch alphas and betas once in a while. The alpha, beta, theta is really different. Right, this one here was another different thing for us, other than negative angles, is this the first angle, the alpha angle lands there. The beta angle loops all the way around. It goes greater than 360 degrees. So we can get an angle that goes around, around, around. You watch snowboarding or skateboarding competitions, don't they say talk about moving 540s, right? Up to 720s. And that's getting your angle to go around more than one time. Okay? Alright. It's always great when I teach this lesson and they want you to look at this. Alright, the measure of an angle is the amount of rotation required to rotate one side, called the initial side, to the other side, called the terminal side. So you measure it by how much distance there is in between. In either degrees or radians. Okay? So we're going to kind of talk about what a radian is. Before I do that, it talks about central angle. It's an angle these vertexes in the center. We've had that last year in geometry. We also had in scribe. We're not doing the scribe. Okay? It's basically just know what comes out of the center. So officially a radian is the measure of the arc divided by the radius. That gives us 1 radian of the circle. Okay? Which they say is equivalent to ours. So basically what they're saying is that they're taking that radius length and they're laying it on the circle, and that is the length of a radian. Okay? So whatever the radius length is the length of a radian. If I was to take and I was to lay that radius around the circle, okay, and I had an activity that I used to do with you guys, and I chose not to do it this year because it doesn't turn out anyways, so I decided to skip it. But where if we laid that radian out around the circle, it would land 6 times with a little bit of it, not quite 6 times around the circle, right? A little bit more than 6 times. So we would be able to lay that radian around the circle. So we're going to talk about the central angle of 1 full revolution. So if I went 1 full revolution around in radians, how much is that in degrees? It's 360 in degrees, right? Well, in radians, it's 2 pi. Okay? And technically, they're saying 2 pi r. What is 2 pi r related to? What's that formula? Based on the circumference, 2 pi r. The circumference of the circle. Okay? So 2 pi, that kind of makes sense to us that 1 full revolution around in radians is 2 pi. Okay? So if 1 full revolution is 2 pi, how much is half of a revolution? 1 pi, isn't it? Pi. If 1 full revolution is 2 pi, how much is a quarter revolution? Pi over 2, or 1/2 pi, right? If 1 full revolution is 2 pi, how much is 1/6 of a revolution? Pi over what? 3. So that's one way to get some of these special measures, and then it gives you a picture of all the special measures, right? So here's all the special measures that we have in the circle. These are important ones. These ones come up a lot, pretty much throughout the rest of Trig. So we can have pi over 6, pi over 4, pi over 3, pi over 2, pi, and 2 pi. Do you see how in pi over 6, how many wedges did it cut the top half into? 6. How about pi over 4? How many? And how about pi over 3? 3. Okay, and how about pi over 2? 2. So what if I had pi over 10? How many wedges would I have to put it into? 10. Okay. And do you also notice that it's symmetric across the vertical as well? So see how if I have 6 wedges here, I get 3 in the first quadrant and 3 in the second quadrant. If I had 4 wedges, I got 2 in the first quadrant and 2 in the second quadrant. In the pi over 3 is the only weird one. Okay? When we're odd numbers, it works a little different. 3 is usually the only odd number we use. Notice it does not hit that vertical part. It splits it into 3, so they get about 1.5 each quadrant. Okay. All right, let's look at. I think we already counted. Not yet. We're going to talk about quadranates. Okay. So there are names to the quadrants. We label them and name them with Roman numerals. This is quadrant 1. Okay. Well, remember how we talked about positive going counterclockwise? So our naming goes counterclockwise. This is quadrant 2, quadrant 3, quadrant 4, and they're always named with Roman numerals. I remember that because it makes the letter C. You can remember the letter C is the way you order the quadrants. In that direction. Okay. All right. If I thought about, let's think about it in angles and in radians, because angles makes more sense to us. That's 90 degrees, right? In radians, that's pi over 2. Eventually, you're going to learn the conversion. It's not going to be big. Okay. In this next quadrant, how much is it next in degrees? 180, right? So in radians, we kind of already talked about that that's pi. How much is my next one? 270, good. And then in radians, that is 3 pi over 2. Now this angle here has a lot of names. Okay? First of all, it's where we start, isn't it? So does start at 0. But if I were to go all the way around, what is that? It's 360. So it could be 0 degrees or 360 degrees, depending upon the context of the problem. In radians, we call that 1 revolution is 2 pi. Okay? So we're going to do some counting next. We're going to be able to check our counting because we know that half a revolution is pi and a full revolution is 2 pi. When we get to those marks on there, we should be able to reduce to those things. Okay? All right, so we're going to learn how to right there. Acute and obtuse. So, acute, and this is not news to you, right? You've seen acute and obtuse before. Acute means you're between 0 and 90, or 0 and 2 pi. Sorry, not 2 pi, pi over 2. And then obtuse means between 90 or pi over 2 and 180 or pi. Okay, I don't know if that comes up in the homework or not, but I'm not going to do any examples on that. You should be able to identify whether you're acute or obtuse. Okay. Notice it's not anything greater than 180. It's just said if you go bigger than 180, you can't identify those as acute or obtuse. It's only less than 180. All right, now we're going to count. So I'm going to give you a minute. I want you to draw those 3 circles. And that makes our counting a little bit quicker. Sketch them. You have the little circles, right? You just need to sketch the lines. With 0, right? And we're practicing the counting because the counting is going to help us graph, know where these angles land in which quadrant, and it's going to help us draw their pictures. Okay, so that's what we're going for right now. But we're just going to practice learning how to count in radians. Okay, so first thing I'm going to look at is how many slices of pie in the top half of this. 4, right? So this is going to be my over 4 world, right? So I'm going to count, and I'm going to say that that's 1 pi over 4. My next one would be 2 pi over 4, right? Because I've got 1 and 2 pieces of pie by there. Then I'm going to go 3 pi over 4, 4 pi over 4. How many slices of pie did I have in the top half? 4, right? So I got 4 pi over 4. What does 4 pi over 4 reduce to? Pi, which is what we said we should land on when we're 180 degrees, right? Landed on pi. Looking good so far. My next one, I'm going to keep counting wedges of pi. 5 pi over 4, 6 pi over 4, 7 pi over 4, and I end on 8 pi over 4, which 8 pi over 4 reduces to what? Pi. So did we do okay? See how we have those two checks. We checkpoint at pi and a checkpoint at 2 pi. All right, let's look at the next one. We're going to practice counting again. How many wedges in my top half? 3. So I got my top half is 3, so I know that I'm in over 3 world right now. I always start counting with 0. Then I go 1 pi over 3. over 3, right? There's 3 wedges in the top half. And what's 3 pi over 3 reduced to? Pi. So are we good? Looking good so far? We hit our checkpoint. All right, then it is 4 pi over 3, 5 pi over 3, 6 pi over 3. What's 6 pi over 3 reduced to? 2 pi. So all we're doing is getting, we're just counting. All right, count. Okay, always start counting with 0. How many pieces of pie in the top half? 6 pieces of pie, so I'm now in over 6 for 1 pi over 6. I know my pieces are not drawn really well. I wish they get a little bit closer together there. I didn't divide them. They're not even pieces of pie. 2 pi over 6. My axis is 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6, and we stop and check, right? 6 pi over 6 reduces to what? Pi. So are we on the right track? Yep. Okay. If I wasn't at that point, then I need to go back and figure out where I messed up. Okay. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And 12 pi over 6. Which is what's 12 pi over 6 reduced to? 2 pi. All we learned there to do is just to count the wedges. I'm familiar with it when I'm trying to do the next thing. Everybody got our counting now? Alright, this is your example 1. We're now finally on example 1. Alright, we're going to determine which quadrant each angle lies in. Okay, given the angle measures, given in radians. D and E are a little bit weird. Okay, A and B not so bad. C we'll be able to deal with. Okay, so I'll teach you how to deal with it. So, looking at A, I kind of like to sketch my thinking. Okay, so I'm going to show you how I would think about this problem. So, first of all, look at my denominator. What's my denominator? 4. That means I need to divide the top half into 4 pi wedges. Okay? So am I going to count, is it positive or negative in front? Positive, which means I'm going to count my wedges counterclockwise. Okay, so I know I'm dividing into 4 in the top, counterclockwise. Right? So I'm going to start sketching my 4 in there. There's 1, 2, 3, 4. I'm using dashes because I'm going to only use my solid on my actual angle. Okay? And then how many wedges did I need to count? 5. So my 5th wedge would go right there, wouldn't it? I should really draw my initial side. Now, just looking at that picture, all I have to do is determine which quadrant it lies in. So which quadrant did we land in? Quadrant 3, right? I thought I was doing the next quadrant. Alright, now I got to determine where 5 pi over 3 lands. Okay? Draw my little sketch again. How many am I dividing it into this time? 3, because that's what the denominator says, right? So I've got 1 pi over 3, 2 pi over 3, 3 pi over 3. I gotta keep going, right? 4 pi over 3, 5 pi over 3. What quadrant did I land in? Put my 12 down. Okay. How many do I need to divide the bottom or the 1/2 of it into? 12. So what does that mean I need to divide each quadrant into? It's half of it. 6, right? All of these act very symmetric. Okay? So I'm going to get 6 wedges. Do I want to go up first or down first? Down because of the negative, right? So I'm going to go down and I'm going to divide this quadrant into 6. I'm going to do solid lines. Yeah. 1, 2, 3, 4, 5, 6. What did I need to stop at? 7. So I'm going to go one more. What quadrant did we land in? Third. The answer is a third quadrant on these a lot. I don't know why I didn't know the answer to once I picked the third quadrant. quadrants after it? There pies after it? Sorry, there are radians. Are there pies after it? No. So what you got to do, and I won't put this on the test, but I might pop up with this number because I'm showing it to you. So remember this circle that we had here, and it showed us how many radians about went around. So if I'm thinking about that 4.25, and I'm just trying to figure out what quadrant it lands in, I see 1 radian, 2 radian, 3 radians, 4 radians. What quadrant 0.25 is going to be like right there, right? So what quadrant is 4.25 in? Third. So write down third quadrant for that one. Okay, we'll go back to it in a second. The other one was -3 for answer D, right? -3 would have to put me down first, wouldn't it? So if I think about it, it's going to go about 1, 2, and then not quite there, right? If I mirror what's here. So what quadrant do I land in yet again? 3. So they're both quadrant 3. So if you have something without a pi on it, you go back to that circle in your notes. Okay? These are both end up being quadrant 3. 1, 2, 3. Okay? All right. Now we're going to draw pictures. Okay? I believe this is like your example 2, isn't it? Like that. All right. My PowerPoint has all the things, just the numbers. All right. Now I've got to actually sketch each angle in standard position. Likely we're going to see things that are in the over 4, over 3, over 6 world, maybe over 2. Okay. So, how many wedges do I divide the top half into for 8? 6 wedges. Okay, so I'm going to start dividing, and I'm going to just use dashes. How many wedges in each quadrant? 3. Okay, so I got 1, 2, 3 wedges, and I'm going to go 4, 5, 6 wedges, right? I got to go how many wedges total? 7. So 7 is going to be about right there. Notice how I drew a nice solid line there because that's my actual angle. I should probably also show my initial side. Now, looking at that, if I didn't have my little dashed lines there, just looking at that picture, would I be able to tell if I went clockwise or counterclockwise? No. So the way I do to compensate for that is I draw a little arc in there and pointed arrows to indicate which direction I went. All right, we're going to look at C and D, and then we'll go back to D. Okay, so let's look at C. How many wedges do I divide it into? 3. Do I want to go up first or down first? Down. So I'm going to go down. I'm dividing the 3. That means I'm not, when I do the in 3, I'm not using the axis. So 1. 1. And then 3 would land me here, right? Which is about right, pi. And then I gotta go one more, right? So 4 would land me somewhere there, so that's where my solid is. There's where my other solid is. But this time I would draw the arc going down first. Alright. What's different about D than the other ones? What's missing? There's no pi, right? It's still radian too, but that's where I have to go back and mimic this picture here, right? So all I'm going to do is just draw it in that about the same spot for 2 radians. Not much else I can do other than estimate there. So I would draw it right in here. Make sure my arc is there. Okay. Alright, I want you to take about 30 to 60 seconds and I want you to draw B. So count your over 3s. Okay, make sure you go in the right direction. Okay, check it. So, how many do you break it into? 3, okay, so I'm going to go 1, and then I can stop at 2, right? And so it should have been like that. Alright? Well, not too terrible. Alright, this is your actual example 3 now, right? And it's in the notebook now. I can Okay, we need to determine two coterminal angles in radian measure, one positive and one negative for each angle. This is weird. Okay? We're going to do, so remember how back here, right here in this picture, remember how we showed how we can have a little angle and then I can loop that all the way around and get another angle right on top of it? Like we're taking and we're flipping 540 degrees. Okay? So that's what they mean by coterminal angles. And we're going to try to get one that's the same side with positive and one that's the same side as negative. Okay? That's our goal. Before we reach that goal, we're going to work in one of four worlds. Okay? We're going to either be in the over 2 world, the over 3 world, the over 4 world, or the over 6 world. Okay, so let's go out in the left-hand column. I want you to write something down with me. Before we do that, our goal on this is to add or subtract 2 pi. Of course, that's what I need to do. So to do this process, we're either going to add or subtract 2 pi, because 2 pi is 1 full revolution around the circle. Right? So if I go 1 full revolution, I would land back on top of the same angle. Okay? So let's talk about 2 pi in these worlds. So I'm trying to find 2 pi, an equivalent fraction of 2 pi in over 4 worlds. Okay, I know I could go for 4 first. I can just pick that first. So think about what would I have to multiply that by to get it to 4? What would I have to multiply 1 by to get to 4? 4. So what do I multiply 2 by then? 4. So I get 8 pi. So 2 pi and 8 pi over 4 are the same thing, right? Just renaming it. All right, let's talk about 2 pi in over 3 world. So what do I want the denominator to have to scale up to? 3. So what do I have to multiply the 2 by? 3. So what do I get in my numerator there? 6. So 2 pi and 6 pi are the same thing. Sorry, 6 pi over 3 are the same thing. All right, let's see. I still need to do over 6 world, right? 2 pi, and I want to be over 6 this time. So what would my numerator on that one be? 12, right? Got to multiply bottom, top, and bottom by 6. There's one, it's not in the examples, but I want you to be ready for it just in case. What if I'm in over 2 world? What would I have to do? What would I get as my numerator? Right? So all of those things all say 2 pi. It just depends on which denominator I have as to which one I'm going to use. Okay? So we're going to go ahead and we're going to try to find a positive and a negative coterminal angle here. So I'm going to start by just adding 2 pi and see what happens. So when I'm in over 6 world, I'm going to add 2 pi. I'm going to show the adding 2 pi here, but then I'll write my equivalent fraction. It's 2 pi and over 6 world is the same as what number? What do we calculate over here? 12 pi over 6. All right, so when I add 1 pi over 6 plus 12 pi over 6, what do I get? 1 plus 12. There we go. It's not hard, guys. 1 plus 12. 13 pi over 6. Did I get a positive number or a negative number? Positive. Okay, so if I go back to the instructions, I have to find 2 different coterminals. One has to be positive and one has to be negative. If I added another 12 pi on this, am I going to go positive or am I going to go negative? I'd be positive again, right? So in order to go negative, what do you think I'm going to have to do? I'm going to have to subtract. Okay, so I'm going to go pi over 6 minus 12 pi over 6. So it's 6 pi over 6 minus 12 pi over 6. Negative 11 pi over 6. So did I get one positive and one negative coterminal angle? If I were to draw these angles like we were in the last example, they would all land in the same place. Okay, one might move around more, but they would all land on that same terminal side. All right, let's look at over 4 world now. Okay, so it's a little bit different. You have to watch where your problem starts. Okay, so could I just add 2 pi? When I add 2 pi, am I going to be positive still? Yeah, it's a positive angle. I'm going to start, let's say positive. What happens if I subtract 2 pi to start with? Let's try that this time. A little bit different. What's 2 pi over 4 world? What do we write down? A pi over over 4. Okay, so when I do 9 pi over 4 minus 8 pi over 4, what do we get? Do I get a positive or a negative? Positive. So sometimes, depending upon where my angle starts, I might subtract to get the positive. Okay? However, if I added first to get the positive, I still have a correct answer. So there's more than one correct answer. Now, I have to get to a negative, don't I? If I subtract the negative from here, aren't I just going to say pi over 4 again? So I have to start with this one here. I have to start with that pi over 4 and subtract another 8 pi over 4 from it, which is what? Positive or negative? Negative. Good. I heard the 7. I didn't hear the negative. So it's going to be negative 7 pi over 4. Did we get a positive angle and a negative angle? Yep, that's all we were asking for. Alright, so what kind of an angle am I starting with? A positive or a negative? Negative. So I better add. I know I've got to get to a positive. I could probably start by adding, right? So I'm going to go 5 pi, negative 5 pi over 3. If I'm in over 3 world, what should my 2 pi be? Sorry. Should be 6, right? 5 pi over 3 plus 6 pi over 3. So what do we end up with? Pi over 3. So do we get a positive or a negative? Positive. So we've got one of the angles. We got the positive one. How am I going to get a negative angle? Should I add again? Should I subtract from the pi over 3 or the negative 5 pi over 3? If I subtract from this, aren't I going to get back to this one? So shouldn't I subtract from the original there? Yeah. Okay, so let's go back to, we're going to go negative 5 pi over 3 minus 6 pi over 3, which is going to get me what over 3? Negative 11 pi over 3. Okay? That's coterminal. There's one more thing we're going to cover before we're done today. Okay? And we've got 10 minutes to do it. Okay? Any questions on that? Okay, we do it when we add. The key is adding and subtracting 2 pi, making sure you're in the right world, right? For what your 2 pi is. Okay, complements and supplements. These again should not be new things. Okay? Complement means we add to 90, or in this case, we're going to add to pi over 2. Supplement means we're going to add to 180, or we're going to add to pi. Okay? When we do this, our angles must be positive angles. So I'm going to throw some absolute value bars on there to guarantee that we've got positive angles. Okay? So, we need to find the complement and the supplement. So you might want to write down that this one's pi over 2 and this one is pi. So to get the complement, I am going to do pi over 2 minus 2 pi over 5. And I'm going to throw absolute value bars on it in case it comes out negative. I know I just need the distance in between those two to get my angle. Now, I probably need a common denominator, right? My common denominator in this case. 10, good. So how the pi is going to hang out. What do I have to multiply the 2 by to get to 10? 5. In algebra 2, you guys, I'm not going to multiply top and bottom by 5, right? That's like elementary school stuff. Okay, so I do that part in my head. I decide what my common denominator is going to be, figure out what I have to multiply the numerator. So I know that I would have to multiply the 5 by to get to 10. 2, so 2 times 2 is 4. So my complementary angle was 5 pi minus 4. 1 pi. So my complementary angle to 2 pi over 5 is pi over 10. So those two would add up to 90 degrees. Pi over 2. Okay, let's look at supplementary. Alright, so again, I'm going to use absolute values because I want the positive angle. Okay, so if we get a negative angle, just make it positive. I'm going to do pi minus the 2 pi over 5. What is my common denominator going to be this time? value, that would still be 3 pi over 5, right? Okay, so here's what I want you to do to finish this up, and this is the last one we're going to do. Okay, so I want you to try complementary supplementary on the 4 pi over 5. You will get a negative on the complementary, just take the opposite of it. Okay? Give you a minute to try it. Check it out. So we have to, what do we start with for complementary always? Pi over 2, we're going to subtract 4 pi over 5. So what is my common denominator? 10. Good. So we keep the, what is the pi over 2 equivalent to? 5 pi over 10, and what do you get for the 4 pi over 5? 8 pi over 10. So what is 5 minus 8? Negative 3, and then when I put the opposite values on it, what do we get? Positive. So 3 pi over 10 would be the complementary angle. Alright, supplementary. What do I always start with supplementary with? Pi, and we've got 4 pi over 5. 4 pi over 5. What's my common denominator going to be? 5, and we've got, so we have 4 pi over 5 gets to stay. What's pi turn into? 5 pi over 5, so 5 pi over 5 minus 4 pi over 5 is 5 over 5. Okay, that's where I'm going to stop. Though we only got to example 4, we did a lot because we did a lot of vocabulary, right? We did all the counting. We'll keep working on it, but not until Friday. Tomorrow is March 14th, right? Yeah. We have to do Pi Day, right?